So this topic is about the star and delta connection. What is the difference between the star and delta? So in single phase, we have two wires. One is for phase and one is for neutral. In three phase, we have star and delta. So how the construction detail and what is the difference between these two connections? The star is also called as Y-connected system. So it looks like a shape of a Y. So this is looking like a Y. So we also say this as Y connection. Delta is a Greek letter word. So delta. So it is also called as mesh connection. So what is the construction difference between these two is, in star connection, one end of all the three wires are connected to a common point. So this is all the end or connected to a common point. This point is called as neutral point, and it looks like a Y shape. And other three ends of the wires from the three phases and the common point forms the neutral. The other three wires are three phases. So this is phase line and this is neutral point. This is a construction difference of star. In delta, every wire is connected. Each wire is connected. Each wire is connected to the adjacent wire, the next wire. It is connected to the next wire. So it is interconnected like this, adjacent wires in the form of a triangle. And all the three common points of the connections form the three phases. So this all three common will take three phase supply. This is the construction, the difference between the star and the delta. So next slide. The next slide is about how many wire systems, the configuration systems. So in the star connected systems, we can say two types. One is called a three-phase, three-wire system. So this is three-phase, three-wire system. Also, we have three-phase, four-wire system is also there. The fourth wire, we can say it as a neutral wire in star connection. In delta connections, we have only three-phase and three-wire system. So this is an example I am showing. This is a generator. A star connected generator is producing the voltage. That voltage is connected to a load. A three-phase load is connected. Suppose if this three-phase load is a balanced load, there is no need for a neutral connection here. If it is not going to be a balanced one, if it is an unbalanced system, then the neutral has to be connected, because in the unbalanced, there will be a reverse current flowing in the common point, neutral point. So if this neutral common point, if it is not there, this wire will be constructed like this. It will be connected like this. And this wire. So this wire we can take. This wire will be connected to here. And last, this wire will be connected here. So this would be a connection like this. So this looks like how many conductors, total number of conductors, 1, 2, 3, 4, 5, 6. So it looks like 6 conductors. So to reduce the number of conductors, to reduce the losses, to reduce the cost of each conductor, to reduce unwanted complex type of connections, to make it a simple connection. For these reasons, this common point is taken. The common point of neutral is just connected like this. So this is also same. So now it has reduced to 1, 2, 3, 4, 4 conductors. Previously it was 6 conductors. Now it is reduced to 4 conductors. So this neutral is called as IEA. That is other 3 currents, IEA plus IB plus IC. As I have already said, this will be 0 if it is going to be a balanced load, if it is connected to a balanced load. If it is an unbalanced load, reverse current will be there. The flow of reverse current will be there. So reverse current may flow in this order. So for this we are using this type of neutral wire, which is present in the star connected system. In delta, only three-phase, three-wire system is there. So next difference, we see the next difference. So next difference is, what is the difference between line current, phase current? What is the difference between line voltage, phase voltage, in between star and delta? That is the difference what we are going to see. Here, if it is from line to line, from R to Y, then it is called as line voltage. If it is from line to neutral point, then it is called as phase voltage. Okay, so now VL is equal to √3 of V phase. VL is line current, line voltage. If line voltage is going to be 440 voltage, so line voltage is 440 voltage, what will be your V phase? 440 divided by √3. So that will be 230. So your phase voltage will be 230. If you want to find out what is line voltage, you want to find out what is line voltage, your phase voltage is 230. Then 230 has to be multiplied with 1.732. You will get approximately 440. So this is the difference we have in the star with respect to delta. Delta, we have this VL is equal to V phase. Line voltage, phase voltage, everything is same. That's why we start with the star and run with the delta. So starters, star, delta, starters. We start with the star. So what is happening in star is 1 by √3 times the phase voltage will get reduced. So from this formula, you can say V phase is equal to 1 by √3 times of VL. So that many times your phase voltage is getting reduced. So we can start with star. Voltage is reduced, current is reduced. So less current consumption. In star, your IL, your line current is equal to phase current. Current is same in star. And your power is when we take phase, which is 3 into V phase I phase cos pi. When we take line, then it is √3 VL IL cos pi. That is common for both star and delta. So there is a difference. There is a difference between line current between star and delta, line voltage between star and delta. Power is same. So this diagram, we can see what is the line voltage, what is the phase voltage. So what is the neutral voltage? How much is the neutral is grounded here. Here we can see what is the neutral voltage. So let's reverse voltage. When there is an unbalanced load condition, there will be very less. So that was shown in this diagram. We'll go for next one. Next one is, in star connections, motor speed is low as they receive only 1 by √3 of voltage. The phase voltage is 1 by √3 of the line. So very less voltage. So voltage is less, current is less, motor speed is also slow. In delta, both are same. No, the line voltage and phase voltage is same. So it will be fast. Motor speed is high as each phase gets total line voltage instead of phase voltage. The line voltage, phase voltage is same. Each phase gets total line voltage. Since there's less phase voltage, low insulation is required. So insulation is also reduced. As phase and line voltage are same, heavy insulation is required. So insulation is heavy in delta. In star connection, each winding receives 230 voltage. One windings in star, that is one phase, that will get 230. The last point, star is used in long distance transmission line and delta is used in short distance distributed network. For distribution systems, we use delta connected systems. So this is the main difference between the star and delta connection of a